Hello lovely people, this is the 2017 General Math, or Further Math, what used to be called, Exam 2 Network section. Question 4 here. The rides at the theme park are set up at the beginning of each holiday season. The project involves activities A to O. The directed network below show these activities and their completion time in days. Cool. The two immediate predecessors of activity I, so activity I is here. The activities that are immediately before it are D and an E via the dummy, so D and E. Nice friendly question to start. There are two critical paths. One is A, E, J, L, N. So let's have a look at that one. That's my A, E, J, L, N. There we go. Write down the other critical path. Now after some poking through, hopefully you would find that the other one is going to be A, E, and then via the dummy, I, L, N. Since the dummy dummy I takes 2 and J also takes 2. So it's going to be A, E, I, L, N. A, E, I, L, N. So only 44% spotted that, which is, fairly tricky, I guess. The float time in days for activity F, so that's this one here. Now a nice way to find the float is to compare the longest route involving activity F to the length of the critical path, which we know the length of the critical path is 19. The longest possible route involving activity F, getting rid of that for a second. So I'll just get rid of, I'll get rid of all this, I'll put it back in a second. So I could do A, B, F, and I've either got M or KN. So KN is longer. So the longest possible route involving activity F is 2 plus 3, which is 5, plus 3 is 8, plus 3 is 11, plus 2 is 13. The length of the critical path is 19, so we could delay F by up to 6 days, so that means it has a float of 6, so only 28% got that, which is interesting. I suppose it's tricky if a lot of people try to do it using the boxes for backward scanning, which tends to be error prone, as we can see by that question. There you go. This one here. So the project could finish earlier if some activities were crashed. 6 activities, B, D, G, I, J, and L, can all be reduced by 1 day. The cost of this crashing is 1,000 per activity. What is the minimum number of days in which the project could be now completed? And then the next part, what is the minimum cost of completing this project in this time? So B, D, G, I, J, L. So one way of doing this would be to write out the table and so list every possible route through the graph. There's going to be 1, 2, 3, 4, 5, 6, 7, about 8 different routes through the graph. So that's a little bit annoying. I'm going to approach it slightly differently, but if you're feeling safe and you have the time, list every route through the graph and then see what happens as you reduce them individually. So knowing the critical paths, which is A, E, J, L, N, and the other one, which is A, E, via the dummy I, L, N. Those are both durations of 19. Hopefully in your reading time you've spent a bit of time looking at this network, and so you found other paths through the graph that are close to 19. So we have hopefully discovered ACGN, which is 2 plus 5 is 7, plus 9 is 16, plus 2 is 18. So that's very close to being critical. So ACGN, I should write that in a different color. ACGN is 18. And then if there's anything else that's close to that, which I don't think there's too many other things, A, B would be 5. So we've already looked at the F route, and that's pretty short. We could do like A, D, H, maybe N. So it would be 9. 2 plus 7 is 9. Plus 3 is 12 plus 2, so not really. So, the 18 looks to be the next closest thing, and there's not evidently a lot of other closer ones. Maybe the O. So if we did like A, E would be 10. Plus 2 would be 12, plus 6 would be 18. So the AEJO route is also 18. So I suppose that's another one to consider. Cool. So again, so you'd hopefully spend time in your reading time digging through and just poking around with the graph and seeing if you can find shortest path, longest path, that sort of thing. Again, alternatively, you can write down every list through the graph, and that would also work. But in the interest of trying to be quick about it, we've got ACGN, which is 18, AEJO, which is 18, and then the two critical paths, which are both 19. Now I can reduce B, D, G, I, J, and L. So B, D, G, I, J, L. And we can reduce them by how much? 1 day. Okay. So reducing L by 1 would reduce both of these paths. So both of my 19s would reduce by 1. So reducing L by 1 is good. Reducing I or J would do nothing unless we reduce both of them by 1. So I suppose we have to reduce I and J by 1. That would reduce the overall time by 1. Keeping in mind that as soon as I've reduced L by 1, the ACGN route becomes critical, as does the AEJO route. So I'm going to have to reduce I and J and G to reduce those 3 routes by 1 each. So I've got L by 1, GIJ by 1. So I've got my L done, GIJ done. D is not critical, nor will it become critical, and B is not critical, nor will it become critical. So I'm going to reduce the L by 1 and the GIJ by 1, which is going to reduce my 19 down to 17, and it's going to reduce this 18 and this 18 both down to at least 17, meaning that my minimum number of days is going to be 17 days, and the minimum cost is going to be 4,000. So we've kind of answered both questions at the same time. Again, if you didn't really follow that, the safest bet is to list every route through the graph, so all 8 of them, and then reduce activities one at a time, starting with any of these. Anything that's critical, so the J, I, L, G, that sort of thing, and work through it that way. I'll have a number of videos going through some examples where that does occur. Just didn't do it in this one. So yeah, hope that helps regardless, and I'll see you in the next one.